Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Siti Nur Syafiqah binti Muhammad Zain, metric number AN180126. I will be presenting my final year project proposal entitled Automated River Water Level Monitoring System using Blynk. This project, supervision by Dr. Muhammad Rusdi bin Muhammad Razif and co-supervision by Encik Omar bin Abu Hassan. Floods. Floods frequently occur every year, especially during the monsoon. The flood phenomenon often causes damage to property and the economy. There will be loss and damage of soul and property, lost connection, the electricity will be blackout, and electronic devices such as refrigerator, television and other functionalities will be damaged due to the floods. This project is conducted as an early precaution measure for the residents near the Kelantan River, where it is designed to monitor the water level of the river, measure the intensity of rainfall near the river, and capture real-time image of the river before, during and after the flood to help the citizens alert regarding the current situation at the river. The system and the output of the project will be automatically uploaded into the Blynk and can be easily monitored by the citizen via the Blynk application. The problems arise because of this phenomenon are due to the concerns toward the safety and economy that affected the Kelantan people. The properties such as home essential and transportation usually will be damaged, plus the people are not aware when the floods happening, which could lead to a life loss, while important documents are also could not be saved. Meanwhile, the citizen usually goes to the river to check out the situation there with the awareness that it is very dangerous if monitor the flood near the river manually and could lead to many more misery. The objective of this project is to determine the suitability devices that can be used to predict early flood occurrence. Next, it is to develop a real-time river water level monitoring system for flood prediction purposes. It is also to evaluate the effectiveness of the proposed monitoring system in real river water level application. The scope for this project is, this project requires a camera module. This project needs an IoT system that can connect with the Blynk server. This project is able to detect and monitor water level and footage of the river condition. This project requires stable internet connection. And also, this project will utilize 3 devices connected together in a centralized system to verify flood predictions. There are several technologies for flood detection invented. One of them comes from Siva Kumar Subramaniam. The researchers developed a warning and alert system in real time to monitor the flood areas using radio frequency receiver and real-time information via SMS. It uses contractive and non-contractive sensor as the water detection. Sensor use can locate flood area from 100 meters in radius, and prediction message will be sent whenever there are changes in level, and they use PLC connected to GSM modem to perform the communication at the monitoring station. While in 2018, Melissa Acosta Cole presented the idea of developing a web application to generate an effective response from the people during the flash flood. For every 5 minutes, the information was updated. Disaster risk knowledge is a necessary phase prior to EWS design. It comprises identification and mapping of the risk. In 2019, a project proposed by Amira Hasbullah, a flood warning system based on a water level sensor and an Internet of Things system, has been developed. The HCRS04 has been placed at 2 different levels of water, 0.05 meter and 0.09 meter. When the water reaches its level, the LED will turn on, triggering the buzzer, which will inform both the owner and the local authority, and all of the water level information displays in the Blynk application. The researchers helped me understand the advantages and uses of some of the hardware and software to be used in this project. For the Internet of Things, it provides an effective connectivity to ensure reliable remote communication and data transfer in a wireless environment, and it allows the physical appliance, buildings, automation, software sensor, and other hardware circuit to record and share data without human interaction. As for the ESP32, it is a safe course and is easier to use. It comes with wireless networking and provides a user interface. This ESP32 is used widely in previous projects for monitoring and alerting flood system. The summarization for the ESP32 camera from the previous article are: it is very convenient and suitable for wireless monitoring. It is an industrial wireless control and excellent for home smart device and other IoT application. It also can transmit order to capture images and send them to a smartphone application through Wi-Fi and can be monitored in real time. While for the ultrasonic sensor, it can be placed to detect any changes in the water level and often used for distant measurement application. It is an excellent contact range detection with stable package and high accuracy. Blynk application are stated that it is able to interact with simple input and output commands and can communicate wirelessly with other devices such as ESP32, and it only requires a simple coding processes. The planning of the project starting by doing a literature review and doing a research on previous project regarding the flood monitoring system issue. After having a solid idea and understanding, the project can proceed with the methodology development. Next, software and hardware development, project testing, troubleshooting, and lastly, project analysis. This automated river water level monitoring system using Blynk are the combination of three aspects, which is water level detection system, rain gauge system, and camera system. The output of these three aspects will be uploaded automatically to the Blynk application for user interface. For the water level detection system, when the distance between the sensor and the water surface is reduced from 35 meters to 30 meters, the ESP32 will process the data and send it to the Blynk, and the green LED connected to the ESP32 will turn on. If the distance is reduced to the range between 30 meters to 25 meters, the ESP32 will proceed with processing the data and send it to the Blynk, and the yellow LED attached to the ESP32 will turn on. When the water level keeps on rising and the distance between the sensor and the river surface reduced to less than 15 meters, the ESP32 will process the data and send it to the Blynk, and the red LED connected to the ESP32 will turn on. The shorter the distance, the higher the chance of flood occurrence. The data will be uploaded and displayed in the Blynk application in digit number in real time, and warning message will be displayed. The rain gauge system will determine the amount of the rainfall from time to time. The ultrasonic sensor attached to the ESP32 will measure the water level inside the rain gauge. The ESP32 will be programmed to detect any raindrop level changes inside the rain gauge. Then the data will be uploaded to the Blynk automatically. If the changes are low, it means that the amount of the rainfall is small, and if the changes are high, the rain is heavy and could be dangerous. The data will be uploaded to the Blynk application in graphs in real time. This camera will be programmed to capture images around the river every 1 hour to monitor the situation. Then the images will be uploaded to the Blynk application. So for this project, data collected from all devices will be shown in the Blynk application to provide a concrete prediction and guide of possible floods in the Kelantan River. As we can see in the diagram, this is the experimental setup for the project. For water level detection system, the IR laser distance sensor will be attached to the ESP32 controller, while for the rain gauge system, the ultrasonic sensor will be attached to another ESP32 controller to measure the rainfall level inside the rain gauge. These two systems and the camera will be attached to the upper part of the Kelantan River Bridge to monitor the river. All the output will be connected wirelessly to the Blynk application. Hardware specification: the ESP32 wireless controller equipped with Bluetooth or BLE and Wi-Fi wireless connectivity feature. It has a built-in CP2102 chip, which allows user to plug it to a computer directly without the need of an FTDI programmer to program. This type of microcontroller is built with low input power consumption, which is suitable with any kind of power scaling needed by any project. ESP32 camera is very small and portable. Unlike the ESP32 module, this camera module needs an FTDI programmer to program. This powerful tiny device supports low power 32-bit CPU, image Wi-Fi upload, and has a built-in flash lamp. FTDI programmer is to program the camera. As for the ultrasonic sensor, the operating current needed to operate is less than 15 milliampere, and it has a measured covering angle from 0 to 15 degree. This sensor is used up to 80 centimeter range detection. IR laser distance sensor. The model chosen for this IR laser distance sensor is SEN0366. Infrared laser distance sensor can measure distance up to 50 meters. This sensor is very cost effective because it varies with excellent famous features such as long distance detection, high accuracy, small field of view, and visible IR laser. The accuracy for this IR laser distance sensor is 1.0 mm. And the single measurement time expected is from 0.05 to 1 second, which is fast enough for our application. Software that will be used in this project, which it is Arduino IDE and Blynk application. The expected outcome for this project is the people near the flood area will be notified regarding the situation and the status of the water level via the Blynk application. As for hardware development, minimum troubleshooting is expected, and the connection of the system with the user interface Blynk application is strong and solid. The people near the flood area will be notified with the incident data via Blynk application, and they can be ready at any time and could prepare themselves for the upcoming hazard. For this project, we already started taking data from the sensor. We managed to start the project with the rain gauge system. These are the output of the output and the connection that already been made, and Wi-Fi communication between the ESP32 and Blynk application was also connected successfully. The performance of the ultrasonic sensor also has been tested and plotted. As for the conclusion, this project is expected to achieve the objectives. The automated water level monitoring system using Blynk are progressing and are in a developing process. The hardware chosen are also compatible with the project and could operate successfully. The Blynk application can be viewed and monitored clearly, and lastly, the sensor can give an accurate measurement for the floods monitoring system.